Hello everyone, today we're going to discuss union and intersection of sets and the difference of two sets. We're going to illustrate union and intersection of sets. We're going to illustrate difference of two sets. So, we're going to make use of the Venn diagram wherein it is very helpful in illustrating union and intersection of sets. So, this is the visual illustration that uses circles to show relationship among sets. So it was named after the English logician John Venn from 1834 to 1923. So let us start with the joint sets and the disjoint sets. So let us have the difference between them. So for the joint sets, okay, so these are the sets wherein they have some elements in common. So let's say we have set A and then set B. So set A is the set of wherein this is the set of odd numbers from 1 to 11. We have 1, 3, 5, 7, 9, and then 11. And then set B, we have numbers from 1 to 5. We have 1, 2, 3, 4, and then 5. So if you're going to notice that from set A and then set B, they have elements which are common, which are the same. So we have 1, right? We have 3, and then we also have 5. Okay. So if we're going to make use of the Venn diagram, this is now the illustration of that. Okay? So we have here two circles that overlap each other. So the common elements are 1, 3, and then 5. So for the disjoint sets, these are the sets wherein they do not have any element in common. So let's say we have two sets. Set D, we have 2, 4, 6, 8, 10. So these are the sets. The first set is the set of all even numbers, and then set E, we have the set of all odd numbers. So notice that they do not have element in common. So if we're going to make use of the Venn diagram, this is the illustration of that. So two circles are separated from each other. So this is set D and then set E because they do not have common element. Next is the union of sets. Is the set of all elements formed by two or more sets. So in the union of two sets, A and then B, denoted by AUB, or we read this as A union B, is the set of elements which are in A or in B or in both. So let us have set A and then set B as a joint set. So let's say we have set A, the set of all odd numbers from 1 to 11. We have 1, 3, 5, 7, 9, 11. And then set B, we have numbers from 1 to 5. 1, 2, 3, 4, and then 5. So let us get the union of this. So we have here the union is A union B is equal to, so what are you going to do is you will just copy all the elements from the first set. So we have 1, 3, 5, 7, 9, 11. And then from the second set, we have 1. We already have 1. Then next is 2. Then we already have 3 also. And then next is 4. And then we already have 5. So as you can see, it is the union of all elements of the two sets. So we can also arrange this one that we have 1, Let us rearrange this. We have 1, 2, 3, 4, 5, 7, 9, and then 11. So, okay. Next is, let us represent union of sets using the Venn diagram. So, let us make use of two circles. Okay. So, this is set A. Let us write here 1, 3, and then 5. And then here we have 7, 9, and then 11. Then let us make another circle. Then let us draw it. Okay, we have to consider the elements 1, 3, and then 5. So we have here elements 1. We already have 1. Then we will just write here 2. We already have 3. Then we have here 4. And then we already have 5, right? So let us shade these two circles. Okay. Okay. So all of the regions of two sets, or set A and then set B, are shaded because union means or put together. Okay. So union means or put together. Okay, this is the illustration of the union of sets. Next is the intersection of sets. Intersection of sets is the set containing elements common to the given set. So the intersection of two sets A and then B, denoted by or written A upside down U B. So we read this as A intersection B is the set of elements common to both A and then B. So using our example, previous examples, we have set A. So the elements are from 1 to 11, all numbers, odd numbers from 1 to 11. We have 1, 3, 5, 7, 9, and then 11. Then set B, containing numbers from 1 to 5. 1, 2, 3, 4, and then 5. Now, to get the intersection of these two sets, we're going to go through the elements of the first set and see if they are in the second set. So, A intersection B is equal to, so let us see. So for set A, 1. So 1 is in both sets. 3 is in both sets. So we have 1, 3. 5 is in both sets. So A intersection B is equal to the elements 1, 3, and 5. If we're going to make use of the Venn diagram, so we have here set A. Let us draw circle. We have 1. We have 1, 3, 5, 7, 9, and then 11. Okay, so for set B, let us make another circle, but then we have to consider elements 1, 3, and then 5. So we have to write it. We have to include, okay, 1, 3, and 5 here. Okay, so that's B. So let us. Okay, so this is set B. So we already have 1. Okay, then we already have 3 here. So we will just write 2, this one. Then we will write 4. Then we already have 5 here. Okay, so as you can see, we have here the intersections. We have 1 elements. We have 1, 3, 5. So we're going to shade this part. Okay, so these are the intersection of the two sets, elements 1, 3, and 5. So intersection means overlap, right? So intersection means overlap. Okay, so that's it for the intersection of sets. Now next is the difference of sets. Now for the difference of sets, for sets A and then B, the difference of A and then B was formed by all elements in A, but not the elements in B. So again, given the two elements, the two sets rather, A and then B, we have elements, set of elements from 1 to 11, add numbers from 1 to 11, we have 1, 3, 5, 7, 9, and then 11. And then for set B, we have numbers 1 to 5. We have 1, 2, 3, 4, and then 5. So if we're going to get the difference of this set, so from A to B, we have A minus B. We have A minus B. So this is equal to, so we're going to minus 1. Another one, we have 2 minus 3. Then we have 5 because these elements are already in B. So we have remaining elements 7, 9, and then 11. Okay, so A minus B is equal to 7, 9, and 11. So let us have an example. Let us illustrate the union, intersection of sets, and the difference of two sets. So we have here set M, A, T, and H. So for set M, this is the set of the days of the week, meaning to say from Monday to Sunday. Set A, we have elements Monday, Tuesday, Thursday, Friday, and Sunday. Set T, we have elements Tuesday, Wednesday, Saturday, and Sunday. Set H, we have elements Monday, Wednesday, and Friday. So let's start with number 1. A union H. So meaning to say we have to combine all the elements of set A and then set A and then set H. So we have Monday, we have Tuesday, we have Wednesday, we have Thursday, we have Friday, then we have Sunday. So all of this. So let us write. We have Monday, Tuesday, Wednesday, Thursday, Friday, and Sunday. Okay, next, number 2, we have A intersection T. Okay, so meaning to say we're going to get the elements common to both A and T. So what are those? We have Tuesday, okay, and then we have Sunday. Okay, so we will just write here A intersection T is equal to Tuesday and Sunday. Okay, next, number 3. So H minus T. So we have to remove elements in H that are also in set T. So we have to remove Wednesday. Okay. Okay, that's it. So we will just write here Monday and then Friday. Okay. So we have Monday, Friday. Next, number 4. Number 4, let us make use of green. Okay. So number 4, we have T union H. So again, we're going to write all the elements in T and then H. So we have here Monday, Tuesday, Wednesday, Friday, Saturday, and then Sunday. Okay, next, number 5, M minus A. So set M and then set A. So again, we're going to remove elements in set M that are also in set A. So if set M has the elements, okay, from Monday to Sunday, so we will just remove Monday. Okay, we'll just remove Monday, Tuesday, Thursday, Friday, and then Sunday. So the remaining days of the week are, we have Wednesday, and then Saturday only. Okay, so that's it. That's all for today. Thank you for watching the video about union and intersection of sets and the difference of two sets. So subscribe and then click the notification button for more videos and updates.